Okay, hello everybody. Let's do the next one. We're going to just draw some plots. So we have everything we need to know just by looking at these two equations. And really we only need to look at the update equation here. And specifically, we need to look at the coefficient here to notice that 6 over 5 is bigger than 1. So we have an explosive system. So there is a steady state. But if we leave that steady state in any way, if we go a little bit up or a little bit down, then we will continue to explode to either plus infinity or minus infinity, in whichever direction the perturbation is. So all of these plots are going to be roughly the same. We'll have time here. We'll have pi here. We can assume the system is in the steady state. We'll start at pi star. So this is the only stationary point of the system, and it can carry on flat. But if we increase the target inflation rate, which is here, there's a minus sign. So if it goes up, then there will be a minus shock to pi t, which means that the system will immediately diverge to minus infinity. And then, of course, the opposite is true for number 2. So this is case 1. In case 2, we get a decrease. So minus becomes a plus, and so it gets bigger. So we're knocked off the steady state, and we go to plus infinity. Yes, and the same thing is true for 3 and 4. The only difference is in 3, we have only a single shock. So if we begin at a steady state, and then we have a single shock of 5, okay, so it's a positive shock. It's 6 over 5. So if it's 5, we'll get a value of 6. So we go plus 6. And then we continue to diverge to infinity. This is case 3. In case 4, it's slightly more subtle, but I mean the plot will look roughly the same, just that there's multiple shocks. And there's two things going on at once. There's going to be the divergent behavior of the system itself, and there's going to be the additional shocks. So we begin at pi star, we move steadily, we get a shock, we go up. We get a shock and we go up, say to here. Okay, plus 6. Now we're going to have some kind of, we're going to have another plus 6 plus 6/5 pi t, right? This isn't 0 anymore, so it's going to be even bigger. And then the next one's going to be even bigger and then even bigger. So it's still diverging to infinity, but we're getting these additional bumps to help it along the way for 4 more periods. 1, 2, 3, 4. Okay. Now if this weren't unstable, if this were stable instead, you would have like a battle going on between the shocks and the reconvergent behavior. So if we were to imagine that this was stationary, we get the plus 6 shock. So we carry on here. We get a bump to plus 6. And then we would reconverge. So we could imagine that if nothing else happened, we're at plus 6 on the other side. If there were no more shocks, we would come back down maybe to here, right? We would start to come back down, but there's another shock, so we get another plus 6. So instead, we end up minus this and then plus 6. So we come up to here, and then we would play the same game again. If there were reconvergent behavior, we would start to reconverge from here. Maybe we would come back to this point, but there's not, because there's another shock of plus 6. So we would come to here, but then we add 6 more. So we come to, let's say, here instead. And we do that for 4 time steps, and then we get our reconvergent behavior. Okay, so that's just multiple positive shocks again and again and again. And all of these up motions, these distances here, so this distance is 6, this is plus 6, and these distances, this one, and this one, are all smaller than 6, because it's being offset by the natural tendency of the system to go back down. Yes. Okay. So that's that. Let's look at the next ones. Oh, I guess it asks you to plot everything. I mean, IT, YT, pi t, but the point is just that pi t drives all the dynamics. So you would just go back and look at the initial equations from the question and plug in pi t, right? So IT, yeah, you would need to get out your solutions for YT as a function of IT, and then IT as a function of YT. So you take IT, put it in. And I think just everything's roughly the same. It's a scaled version of each other, just that YT is upside down. Just so, yeah, IT will look just like pi t. If pi t looks like this, then IT will look like this as well. But then YT will be upside down. YT will look like this. Something like that. You can check the notebooks for how these graphs actually look. Just understand, in principle, you understand that what you would do is you'd compute the state variable, and then you would go through the list of jumpers and compute the next values. And you can see what that would look like by just, all of these are linear, and then you see that the coefficient on YT with respect to pi t is negative, so it's like a mirror flipped version of it. Okay, I will see you in the next video.